In this module, we shall learn the properties of an ellipse. Let us recall that for an ellipse with a center C at the origin and major axis along the x-axis, the distance between the foci is given by 2c. The length of the semi-major axis is A, and the length of the semi-minor axis is B. The eccentricity E is equal to C upon A. The standard equation of an ellipse is given by x square upon a square plus y square upon b square equal to 1. Now let us derive the relationship between the length of semi-major axis, length of semi-minor axis, and the distance of focus from the center of the ellipse. Recall that the distance from the center to the foci is c. The length of semi-major axis is A, and the length of semi-minor axis is B. As per the definition of an ellipse, the sum of the distances of any point on the curve from the foci is a constant. Points B and Q lie on the ellipse. Therefore, BF1 plus BF2 is equal to QF1 plus QF2. From the figure, we can say that BF1 plus BF2 is equal to the sum of C plus A and C minus A, which is equal to 2A. Call this equation 1. In right-angled triangle QOF1, according to the Pythagoras theorem, QF1 is equal to the square root of B square plus C square. Similarly, QF2 is also equal to the square root of B square plus C square. Substituting these in equation 1, we get A square equal to B square plus C squared. Now let's look at a new term associated with an ellipse called the latus rectum. Latus rectum of an ellipse is a line segment perpendicular to the major axis through any of the foci and whose endpoints lie on the ellipse. Now, we will derive the length of the latus rectum. Let the length of RF2 be L units. Then, the coordinates of R are C, L. Now, as R lies on the ellipse, its coordinates should satisfy the standard equation of ellipse. Thus, by substituting C, L in the equation, we get L square equal to B square multiplied by the ratio of A square minus C square and A square. Call this equation 1. But we have B square equal to A square minus C square. Substituting this value in equation 1, we get the value of L as B square upon A. Since the ellipse is symmetric with respect to y-axis, RF2 is equal to F2S. Therefore, the length of the latus rectum is 2 times B square upon A. Next, let us see an example. Find the coordinates of the foci, the vertices, the length of major axis, the length of minor axis, the eccentricity, and the length of the latus rectum from the given information. Comparing the given equation with the standard equation, we get A equal to 7 and B equal to 6. Use equation C square equal to A square minus B square to find the value of C, which is the distance of the focus of the ellipse from the center. Substituting the values of A and B, we get the value of C as square root of 13. Therefore, the foci of the ellipse are given by minus C, 0 and C, 0, which in this case is minus square root of 13, 0 and square root of 13, 0. The vertices A and B of the ellipse are given by minus A, 0 and A, 0, respectively. The length of major axis is given by 2a, which is 14, and the length of minor axis is given by 2b, which is 12. Eccentricity is given by c upon a, which is equal to square root of 13 by 7. Finally, the length of the lattice rectum is given by 2 times b square upon a, which is 10.28 units. Now let us summarize what we have learned in this module. The length of the lattice rectum is given by 2 times b square upon a. Relationship between semi-major axis A, semi-minor axis B, and the distance of focus from the center of the ellipse C is given by a square equal to b square plus c square.